I'm not sure how the quizzes are ordered. You can probably click to maybe organize by due date if you want. I would have thought if they're alphabetical. Oh yeah, I would need to just have it 09010203. Yeah. So maybe just organize by due date. Yeah, that's unfortunate. Yeah, I'm so surprised that there's a rather low number of submissions for this one. Looking at the stats, I guess 33 out of 75. So again, almost 50% of you thought that maybe it was mostly too long just due to the fact that it was hard to do this on Connects, which I completely agree with. Some of you thought it was too long regardless of the format. And then a few of you maybe thought it was a little too long or about right. And some of you also a little short. So yeah, can I do the next one? Yeah, and in terms of whether or not like kind of difficulty, I guess a lot of you actually felt pretty confident. Again, half of you thought you could answer your confidence, I guess, even if you add these two together. A lot of you were quite confident, whereas again, 17 of you thought that some were a little too difficult, and some of you many. So again, I think so. First of all, what I can say is, so I actually wrote the midterm up on paper first, and just to kind of see how big it was and how it kind of compared to other exams. And again, obviously there is a lot of writing here. I think, but I do think, again, the format, again, all I was expecting for the on Connect was just kind of stuff just like this, just kind of pretty small expressions. This was just a single answer. And I'll post this on Friday. I was hoping to get the grading done, but we're still working through it. I started at the beginning, and as TAs have been able to join in, I've kind of assigned them different questions. Certainly for the first question, I think the majority of you got, I think, yeah, the majority got 100% on these first 10 marks out of 45 in the whole exam. So that's good, at least. I know the problems came later in the exam, specifically for the last question. Whereas when I looked at that, there was quite a few no submissions. So there are a few things that we can do moving forward. Again, I still want to wait until the exams are fully graded. And I can maybe go over, and I'll post this hopefully today when we finish the grading, and give you a chance to kind of look over stuff. But there,
Can I ask a question, sorry?
We can do depending on what the final average ends up being. And so I talked with Rich Little, who's the instructor that typically does CSC 225 and 226. He's the one that set the schedule for this course, including what I should do on each lecture and each lab. And yeah, and I can look into different Connects issues. Yeah, I'll get your question in a second, Lucas. And what he said is his last exam, this midterm one, when he did kind of mostly focus on discrete math, actually had a 50% average as well, just even on paper. And he said he did scale it. So obviously scaling is an option. Things I've done in other courses have actually been allowing people to shift some of the weight. Like, you'd have to decide beforehand, but we could shift some of the weight from midterm 2 on the other exams. So maybe this exam's worth 5% less, and the other ones are worth 2.5% each more. And I also talked with him about different exam formats. Something he did was actually posted the exam at kind of 4 o'clock and said you just have to submit it like an assignment by midnight. So you kind of had the evening 8 hours to do it the same way you would regularly do the assignment. You had to submit a PDF, but it could have just been, you could take a photo of your work with a camera and submit it that way, or do it in Microsoft Word or whatever there is. And I know that's what someone asked about a few days before the exam. So yeah, there are some things that I'm gonna, now that almost all of the courses this summer have had their first midterm, I'm gonna meet with a whole bunch of other instructors and we'll kind of talk about what worked and what didn't work. The senior lab instructors who seem to be have a crossover. A lot of the teachers or TAs for a lot of the same courses have said that it's kind of been really polarized. Like a lot of the exams have been really too long and the average has been really low, or it's been the exact opposite and exams have had like almost like super high averages, but there hasn't really been anyone in the middle yet. So yeah, Lucas, what was your question? Oh, sorry.
Sorry. It was more a comment. I just found it more difficult for the one where you had to like do the proof by I think it was which one was it?
Proof by induction?
The recursion one.
Oh yeah, the very last one. Yeah.
Or no, the loop invariant, sorry, or something.
This one with the high fives?
Yeah, just because like a lot of the ways I just found a lot of it really difficult doing it on the actual like typing it out.
Yeah.
Just because like all the practice we've done and stuff has been writing and like by hand and stuff. And so that was kind of just, as soon as I got into the exam, it was kind of put me off guard.
Yeah, and that's something we, as I said, we'll do. I certainly think that I'm open to having that submission system open. I mean, so one thing I try to do with these questions, which I was warned about as kind of the main thing going in, is again with this test being online, not making the questions Googleable. So again, if this question was just kind of the same as having kind of 3 red candies, 2 blue candies, and 3 orange candies, how many times can you arrange the letters in this word? But I couldn't just say how many times can you arrange letters in Mississippi or something like that, because it's just such an easy way to Google and just find all the answers right away. So all the questions, I kind of tried to create them based off of stuff we've done in the worksheets, but not in a way that were just easily, you could Google and just find a whole explanation you could copy and paste. And that's kind of why this was like a slight variation of what you did in the lab. This was essentially sum from 1 to n-1, but dressed up in a way that you couldn't just Google what's the proof of induction for sporting event high fives. And this one was a picture. So I tried to make it so it was kind of doing a lot of the same things we'd done in class, but in a way that they weren't Googleable. And I think maybe this exam, when the TAs wrote it, they thought it was okay, but I guess maybe again, if it had been something where you had an hour and a half or something like that, where you could actually write it up and then figure out a way to take pictures of it and upload, it would have been okay. Let me just read the chat for a second. Yeah, that's the thing, Omar. I hadn't actually even heard of Chegg before, but a week, like about 5 days before the exam, I was told about it, which scared me a bit. So that's why I had to kind of re-flavor all the questions, just because so much stuff is on Chegg. Sabrina's saying the length plus 10 minutes and doing on paper would be okay. Yeah, so again, the nice thing I can do with Connect is I actually randomize these numbers. So there was different variations, which is also why I graded that question, because it was slightly different for each version of the exam. But you guys all had, I think, between 3 and 4 red candles, between 1 and 4 blue, and between 1 and 4 orange, I think. So again, different variations of the same question, but again, all the same kind of process here. Yeah, so I think the most you probably could have got was 433, I think is how I said it. Maybe I think the most you had ever was, 10 in total, I believe. Yeah, but again, if I put this out as a PDF and a docx like I do with the worksheets and had people to submit a PDF and a worksheet, then I guess I could still have the questions posted in the quiz tool. I was just thinking I couldn't randomize this if it was just everyone had the same PDF to work from. But I guess I could just have the questions in the connects tool and you submit it as an assignment. Max marks, well, right now the max marks is 45. We'll see what happens after we get to look at all the grades and everything. Yeah, it seemed like most people are getting between 8 and 10 on this on this first page. The biggest issue for this second one was the fact that n factorial is actually the worst, is what I saw for this one, the most common thing. Because we talked about how exponential is really bad. So 2 to the, 2 to the n. And this, our log rules just make this n, but 2 to the n is like multiplying 2 n times. So 2 times 2 times 2 times 2 times 2. If you think about n factorial, that's multiplying n times n minus 1 times n minus 2 times n minus 3. So it's actually worse than multiplying 2 n times because you're multiplying numbers larger than 2 n times, except for at the very start. Yeah, I'll post these solutions. That was the kind of the main thing here. And I guess for the log n runtime one, the main thing about loops that are log n is that you're going from like 1 to 2 to 4 to 8 to 16 to 32 again. So the number of iterations is log n, because I guess your I variable is kind of all the different powers of 2. So I was looking for, if you start at 1 and add it to itself, it's going to go 1, 2, 4, 8, 16, similar, multiplying it by 2 each time. And the exact opposite is if you start at n and divide by 2 each time. This I think this was because this is just going to go down to just n, and this is then 1000 n. So these are kind of the same asymptotic running time. Yeah, you'll get part marks. These ones were automatically graded, so I have to override the grades. So some of the ones you'll see that it gave you a whole bunch of X's and you've got a higher grade than what it gave you. And that's because, again, if you organize one wrong, I still try to give you most of the marks, so I had to override that. So we'll see. When there obviously will be some regrades especially for the auto-graded components that might be different. For this one, I think I gave a point for each one you got right and minus half a point for the ones that you circled incorrectly. This one's being graded. This one's being graded. But when I took a quick scan, it seemed like these were mostly okay. And this one was tough. And so this is, I want to wait until this is fully graded to see what happens. Again, I think on paper, again, this is way easier on paper when you actually even like getting the pattern is probably a lot easier if you can actually even just like do this, right? And kind of count up how many there are in the next iteration. And then from there, you can kind of start seeing the pattern and see, oh, wait, they all just go up by 6. So again, something like this is just so much easier on paper. People that are fastest, slowest got 0 by the auto grader, but I switched that to full marks. Yeah, so you should all get full marks if you did the exact opposite. I did try and specify, like I said, 01 would be is considered fastest, I thought. But I can double check. I thought that's what I did. It's going to give people PTSD if I open this right now, though. So I said, order the following from growth rate. For example, 01 would come first. So I was trying to say that the fastest should come up here. So that's something I talked about. I'm not actually grading the last question, but so the problem here is that if you got this part wrong, it's going to be hard for you to get this part right. So I think, again, if you got this part wrong, you'll you'll miss some of the marks here, but if you still, based on whatever your formula was, assuming it's not just something super trivial, and if you showed you understand the process of doing substitution to get something here, obviously the value is going to be different, but if you, this question, part 2, is supposed to show that you know how to solve a recurrence equation by repeated substitution. And if it was, again, if your equation had some wrong variables here, but you still did the substitution correctly and came up with the closed form based on, and solved it based on doing the process correctly, I think you'll still get grades there. But a lot of, again, what I saw is a lot of this was just blank. So that's why we're gonna have to revisit how to handle the marking for this. I actually added this question near the end because I thought it was actually too easy like this. Well, I just thought without it, all this question was people getting to see if people could draw the circles correctly. So I added this and then took off some other questions because I thought I actually didn't really have a good grasp gauge of how difficult the exam was. I thought when I wrote this, I thought that everything was somewhat less challenging than the assignments, and I thought if people had the assignments open, it could be quite easy to kind of see, compare, and translate over. And I thought this was the only one that was a little bit different, so I added it. But I think maybe without this, the grades would be really high. Really common is 2cn minus 1 plus 5. Yeah, that was, I think, the most common solution. Which I didn't actually realize it, but it works for the first three cases, and then breaks n equals 4. Yeah. I think this one was, but I think this, this is proved by induction that the sum from 1 to n minus 1 is n minus 1 over 2, which is just the summation from 1 to n minus 1 of I, which is really like the almost textbook induction proof. It was just that I dressed it up differently. Yeah. So there was a lot of just summation stuff, which is something else I talked about with Rich. I think, again, we don't really need to talk about this now because it doesn't really affect you, but we talked about even the first week when a lot of this discrete math stuff is supposed to get you ready for kind of being able to do counting for runtimes and stuff like that. And I was asking why the binomial theorem is covered, because we spent kind of, this was a pretty big video and we spent some of the time in the lecture covering that. And I said this one could maybe just be a lecture on, instead of binomial theorem, talk about just summations. And like, here's really common summations, 1 to n squared, and just go through these really common summations and the closed form of them. Because I think those come up way more often in the next kind of 3 or 4 units. And he agreed. So I think in the future, they probably won't talk about binomial theorem, but they will talk about some of the common ways of counting, which I think will be more applicable to some of the counting, the proofs, the asymptotic analysis and stuff like that. Because it did seem like, some of you are certainly getting it, but some people certainly are still maybe, again, maybe just kind of forgot because the stressful exam environment, or didn't have enough time. Obviously, a whole bunch of different factors that come into play there, but that's why I think just more practice early in the course would probably benefit. Douglas, so you're saying if you'd been given this, it would have been quite easy. Yeah. Yeah, I agree. So, so I mean, it does say, because there's no final, and a lot of computer science courses have a must-pass final. I said you must pass the average of the midterms. We'll see. Again, I'm gonna, depending on whether or not we can shift weight from this midterm to the other one or scale it, we can talk about that when the grade distribution's out. When I checked, last I checked, there were still some people going that were, I think with 2 questions left to mark, we're at 100%. Not many, but certainly some. So there's a few of you that did quite well. So I just got to figure out, I've never actually had to curve an exam before. So I just got to figure out the right way to make it fair for everyone involved. Because again, I want people that, again, because of the format and because of just this being the first kind of online exam, there are a lot of factors that I think many of you weren't able to demonstrate your knowledge. And again, as an instructor, I want you to be able to demonstrate what you've learned in this course. So I want people that have learned something to be able to demonstrate that and get the grade they deserve. But I also don't want the people that did really well to be penalized for doing really well. So I want to make it fair for everyone. Yeah, so the problem is it sounds like it's great for everyone to get 100%, except for the people that spent 200 hours studying and actually got like a 98% even with this exam. And then all of a sudden, the people that maybe, I mean, there are some of you that put in a lot of work but didn't get a great grade, but there also might be some people that kind of were just casually not too worried about the exam and didn't do well. And all of a sudden they get the same grade as people that really, really worked hard. So I do think, again, earlier when in my career, I did want everyone, like my goal was just to get the class average as high as possible. And I do want my class averages to be high, but I do also want to make sure that the people that work hard are rewarded for learning the material well. Because again, otherwise if everyone does well, there's not a lot of motivation or reason to actually try and excel. That's something I mean, that's an argument for another time about how much grades actually matter. There are certainly things where it's good to have good grades. Obviously, there are other things that matter in life as well. So yeah, so shifting the weight has worked. So I've never scaled an exam. I have shifted weight before at UBC, and that has worked. The other thing we did that I didn't like so much was people actually were able to take some sort of like the max of like if they did better on the midterm 2, their midterm 1 was pulled up a certain amount. So like if you're showing, like if you can show that, oh no, like look, I really kind of turned this around and I was able to do well in the second midterm, it can bring up your first midterm to a certain point. There's a whole bunch of different ways, but I'll discuss it with a little bit of a committee we'll get going and try to make something that's fair for everyone. Drop the question you did worst on. There's 3 midterms. Yeah, that's something else we could do. And then it's, I guess, dropping the worst question just shows, okay, how well, given the 5 topics, how well do you know 4 of them? It's kind of, but yeah, which is maybe okay. Yeah, that's the thing. I think that, so the 4 parts were split, I mean, somewhat evenly. I guess the runtime analysis is has a few extra marks, but that's because of the multiple choice stuff. I guess if we dropped 5 marks from this, they'd be all kind of within 1 point. And the 5 marks could be dropped by saying you can't drop kind of this multiple choice page, whereas this next page was about I think this was 4 and 5 marks, so 9 marks. So there are kind of 4 main big questions. They're each worth 9 or 10 marks. This is kind of all the discrete math. This is the runtime analysis was 9 of these marks. Induction was 9 marks, and then recurrence relation was 11. Those of you that are saying you got the first page questions wrong, that's going to be different. Again, the numbers are going to be different for every single exam for here. This is just, when I post the solution, it's just going to have these values, but it'll be slightly like, this is essentially the sum of the 3 numbers, which maybe I should do, divided by the number of duplicates. So if your numbers are 4, 3, 3, it'll be 4 plus 3 plus 3 factorial over 4, 3, 3. Maybe I should just put these as A, B, and C, and that'll work better. Which, yeah, maybe that's what I'll do, is just have this as A, B, and C, and then people will be able to do that translation a little bit better. So yeah, I'll change these for when I post it. So they're actually, yeah, work for every exam. Any other questions? Yeah, I'll get the gradebook going. I do have a gradebook going behind the scenes. It's just not, I guess, viewable to students. And what I did in 115 after we had the exam grade is I just posted a PDF that had kind of your grade breakdown there, which I can do for this course as well. Any other questions? Runtime analysis. I think so. The biggest thing for the runtime analysis is most people did this, which is fine. I think you'll probably lose like 1 mark on the whole section of questions for that. That seemed to be really common, but again, I think it's like almost, you'll get almost full marks for that. But yeah, this inner loop is looping, or the inner loop's going from 1 to 4 times the outer loop, and the outer loop's going from 1 to n squared. This is going to go like 4, 8, 12, 16 times, all the way up to 4 times n cubed times. Yeah, there's various ways that, I mean, this is going to be actually, I think, be the hardest question to mark, but the TAs are on it and thinking about the different ways to scale these. Again, some people, their answer is literally just this. A lot of various different constants and stuff here, which I think, depending on, again, if you had 4 times n3 minus 1 or 4n cubed minus 1 like this, you'll get different constants. And again, if you made one little mistake here but then the rest of your kind of process was correct, you'll still get basically full marks. And again, based on what you thought this was, if that correlates with part B, you'll again get the marks. And again, yeah, and that's the thing. We realize a lot of you did this on paper, so there is some stuff missing.
Hey, Anthony, can I just ask a quick question?
Yeah.
So just seeing how you're kind of wording this. So basically, when you have questions that like part B depends on part A, I think what you're saying is if you kind of mess up part A, we're not going to punish you by doing part B correctly, but with the wrong result from part A. Am I kind of correct in interpreting
that? To an extent, like if you said that the T of n of this was like 1, so it like just required nothing here. But if you had something that, again, took about the same amount of work as in part A, then you'll get the marks. Similarly here, if you just had, if your recurrence relation was like C of n equals, I don't know, C of n minus 1, and you showed this by try to solve this recurrence equation, obviously there's not really the same amount of substitution involved, so you probably wouldn't get all the marks. But if you had a similar one, like what people are doing, like 2 Cn minus 1 plus 5, again, that's gonna have a couple steps where you do some substitution, so you get the marks for the part C based on that.
Okay, that sounds pretty fair.
Yeah, or that's at least what we're going for. That's what I discussed with the TAs. Like I met with the TAs that are grading each question and kind of talked about how to split the marks up accordingly. Lucas, you got your hand up again? Or maybe not. Oh, I'll lower it. There we go. For this question? Above this one? I times equal I? That's going to loop forever. It'll stay at 1. Similar to this one. It'll go from n down to 1, and then 1, 1, 1, 1, 1, 1, 1, 1. And it's always greater than or equal to 1. This one will just say 1, 1, 1, 1. And like this one, so really commonly people thought this was log-n and this was log-n. But again, this is just, the difference between these two is just that it's always, as n grows, it's always gonna, like if you've got 1,000 elements, this is gonna go 1,000 times, this is gonna go 500 times. If you've got 2,000 elements, this is gonna go 2,000, this is gonna go 1,000. Whereas log-n, the difference between 1,000 and 2,000 is one iteration. So again, this still scales at a rate that is big O of n, whereas this doesn't. It's every power of 2 is one more iteration. Yeah, there's different ways of doing the runtime analysis. So yeah, we can revisit this a little bit on Friday. What I would like to do, I mean, we are getting a little bit behind on stuff. I think we have enough time if we finish off the insertion sort stuff and maybe even look at this at the merge sort stuff today. On Friday, we're going to complete our last of the sorting algorithms, which is quick sort. I think on Friday we can probably complete our merge and our insertion sort. The other thing that I found out that on the schedule I'm following, which is the syllabus here, which again is discrete math, pseudocode, counting operations, recursion proofs. This is the one I'm following. And again, we're a little bit, we were supposed to kind of, because of the midterm, we're kind of off, but they had a midterm later, so we'll catch up. We've basically been on the exact same schedule, but I also found out in my meeting that this is the proposed schedule, and they actually didn't even finish the last few units. So I think we're doing okay in terms of pace. Yeah, I guess the one other question people had was for the assignment. So I've written the assignment. It's supposed to be posted on Monday. Again, on our official schedule, it was posted on Monday and due next Monday. What I'll do is I'll post it today and have it due next Wednesday or maybe even Thursday next week. The main issue is I want to have both these assignments back to you, graded and back to you before our next midterm on July 7th. So we have a little bit of wiggle room. If we kind of have two assignments that are each due in a week, we do have a bit of wiggle room until July 7th down here. So I can extend them a little bit, but I still want to have that second one due kind of around this time. So we have a couple of days to grade it and get it back to you. But then kind of the first midterm will be on the first two assignments, the second one will be on the second two, and the third one will be on the third pair of two. So that's kind of the general strategy at this point. But I do have it written. It's got some Java programming. It's got some stuff on kind of linked lists and stacks to begin with, to questions that are supposed to be somewhat shorter, and then a fairly large programming question that involves some recursion and stuff similar to the sorting. Any questions? Nope, the first two questions are going to be more just like explain the process of what happens here. So again, just kind of some stuff with doing stacks and queues and linked lists, as opposed to actually programming them up. And then the third one is going to be programming. I'm going to give you a skeleton, some Java code as a skeleton, and some test cases, and you're going to just have to fill in essentially an algorithm that does that involves some recursion and whatnot. So yeah, I'll give you some sample test cases. Obviously, I recommend you doing kind of more tests and maybe bigger tests, and maybe I can get a forum post so you can post your different tests. And again, it'll be graded a lot on does it pass, how many of the percentage of our input tests pass. And there will be, again, I was talking to Rich again about how this is graded. I think there will be some grades based on you get like 5 out of 5 if it's n log n versus 3 out of 5 if it's n squared versus 1 out of 5 if it's like n cubed or something like that. So there is, can you think about ways of doing this that isn't just loop and loop, loop within loop within loop within loop within loop. Where am I going here? This one. Oh yeah, so I think what we had was we finished selection sort and we finished bubble sort, and we haven't done insertion sort. So I actually before class just took off my, I deleted just all the other stuff on this page just so I have more white space to work with. as I'm jotting down stuff. Because I think this, oh, what's going on there? This might help me with some of the annotation. It depends if it's within a loop, it would be, but like you can add a whole bunch of things that are n, and that'll still be O of n. If you add O of n plus O of n plus O of n, it's just when they're nested is things that get bad. But I think once I post the thing, we can get some we can discuss that a little bit on Friday as well. Yeah, then it would be if you called a helper function within a for loop and it had more for loops, that would be multiply those n's to like, if within a for loop that went O of n times you called a helper function that was also O of n, that would be O of n squared. I don't know if you're going to actually ever have to call any built-in helper functions for this. Yeah, you'll see when you do it. It is similar to some of the sorting algorithms we've been talking about. So yeah, we talked about, again, we kind of talked about, let's think about the general runtime of this algorithm, then talked about stability and I guess memory usage. So stability again was if you've got things organized in a certain way in the input array, and there's two things with the same key or the same rank, are they still going to be in the same order once it's sorted? So how, when there's ties in terms of when you're comparing your elements, is order preserved for ties? Whereas memory is how much additional memory is required to run this sorting algorithm. And for those of you that watched the merge sort video, you might have noticed that there was actually some temporary arrays that we needed to use. So we see that the merge sort, when we get into the runtime analysis, we see that it's going to be faster in certain conditions, but the memory usage is also greater as well. But we can jump into this. So again, I think we saw, and I talked about in the videos, that the best case for insertion sort is when the array is already sorted. So how insertion sort works is, again, it's going to have some kind of sorted area of the graph, or of the array. And you'll have some values here that are sorted already. And then you're going to be looking at a new element that you're going to put into the right place. So again, if you've got like a 3 here, it's going to say, okay, I need to swap past the 9 and past the 5. So it's going to kind of rotate these ones back and put that into the right place, giving us 1 and 3 and 5 and 9. And now all of these are, I guess, after this stage, all of these are now sorted, and we will jump to the next element in the list. And again, we see, okay, I want to put this over here, so the 9 is going to solve. So it keeps, that's what's happening here. For how many times do we need to shift this value down until we find that it's no longer, until the item in the array is no longer greater than? So we're grabbing a value, again, like this 7, we're saying, let's keep looping through while this number is bigger than 7. So in this case, and every time we find one that's bigger, we're gonna decrement our j by 1 until we either get to the front of the array, or we find a number that it no longer needs to rotate past. Whereas this 3, it said, okay, I got to go past 9, I got to go past 5. Now I found my spot. This 7 is just going to go, I got to go past 9, then I found my spot. It's not going to go past 5. So obviously, when the array is sorted, it's going to say, how many do I need to put this back? Oh, none. How many do I need to rotate this past? None. How many do I need to, so it's just going to always say, how many do I need to rotate past? But it's never going to find any of these values that are actually larger than it. So it's always just going to say, oh, this is already in the right place, this is already in the right place, this is already in the right place. So in the best case, it is actually going to have to go through all iterations up here. So it will go through the loop iterates n minus 1 times. But each iteration, but in each iteration, there is only a single comparison. Because it's just going to do this comparison once, and it's going to say, I'm going to keep shifting back as long as this value before me is bigger than me, but none of the values before 2, not like 1 is not bigger than 2, so it doesn't have to shift 2 back. 2 is not bigger than 3, so it doesn't have to shift back. So it's just going to make that single comparison and say, oh, I'm actually already in the right order. So it's going to break out of the while loop and go to the next iteration. Does that make sense? I guess what I also noticed that I can do, so now I guess if it makes sense, I don't know if people are near their participant list, but is it really accessible for you to click yes or no? Okay, I didn't realize this. I can then see the number of yeses and nos, which is really quick and easy for me. So it looks like, again, so far it's a bunch of yeses, which is great. So again, what we've got here is we've got n minus 1 iterations, and each time we're doing a single comparison, which is just, which we know is just going to be n minus 1 in total. So again, we see that that's going to be big O of n. So our best case is O of n. We have to actually iterate through this array once. But in our iteration, we're just saying, is this in the right place? Is this in the right place? Is this in the right place? And they're all in the right place. So after doing that first iteration, we're done. Don't see it. So I think in your Zoom call, I think at the bottom, there should be like your mute button, your video button, and then your participants button. And I think if you click the participants button, it should give all the names of the participants. At the bottom of that list of names, there should be like a yes, a no, a go slower, a go faster, and even some other ones like need a break, need a coffee. But it seemed like, yeah, I'm seeing a lot of yeses right now. So this best case scenario makes sense with the way this algorithm works. Okay, great. So now, I mean, typically I'll jump straight to the worst case, and then we can talk about the average case as well. So in the worst case, again, the algorithm is just the exact reverse order. So if we draw that out and and think about what that means, what we're going to have in the worst case is we're going to have this array and for each of our n minus 1 iterations, it's going to say, okay, I need to swap the 36 once. So then we know that we're going to have the 36, then the 42. And then, but all the rest of the values, but then when it tries to put the 25, it has to swap it 1, 2 spots to get 25, 36, 42. And then when it has to swap the 22, it has to swap it 1, 2, 3 spots. So the number of comparisons we're going to need to do is going to be 1 to swap the first one, then 2 to swap the next one, then 3 to swap up to at the very end. This is going to have to compare it with all the way to n minus 1 comparisons. So in the worst case, we need to actually compare each item that we're trying to insert into the right spot has to compare with all the elements that come before it, which is going to be 1 element or 0 elements, then 1, then 2, then 4, then 1, then 2, then 3, then 4, then 5, all the way up to n minus 1. So need to make 0, then 1, then 2, then 3, all the way up to n minus 1 comparisons. So this is going to be very similar to the other one, where we've got this. We're essentially doing a sum from 1 to n minus 1, which is going to be we've got n minus 1 over 2 comparisons that sum to n, which again is just going to be n squared. Because again, we're gonna have roughly n squared over 2 comparisons. So the worst case we see is again n squared, because for each of our n iterations, we have to kind of shuffle back almost n times. Does that make sense? Okay, average case. I'll leave myself to make some room for my stability and stuff. So the average case, again, we could probably say we'll probably have to shuffle about like half of the array. And again, so again, we can kind of think of this as we've got the sum from I is 1 to n minus 1 of, I don't know, I over 2 or something like that, which again is going to be something similar to like n over 4. But again, even if it was n over 8 or n over 16, these are all still going to be O of n squared. So this is considered, again, when things are, again, if you're confident your input data is very close to sorted, then yeah, it'll have pretty good runtime. But on average, again, this is considered the fact that it has to do so much shuffling that it's going to be, again, that this algorithm is expected to be close to the worst case, which is O of n squared. So what do we think for stability in terms of how do we ensure that if 2 items that have the same key that are, again, should be ordered the same in the input array are going to be in the same order once we do our sort? How can we guarantee that? Or what could I change here to make it not stable? Can anyone see that? Yeah. So again, this is important. If this is greater than, it's stable. If it's greater than or equal to, it's not going to be stable. And I can try and illustrate that. So again, if we had, if we've got some items like, and again, so for the first one, we're going to say, I want to swap 2 back into its original spot. So we're going to swap 2 so it comes before 4. So we've got kind of this. And then we're going to say, let's swap 3, the first 3, into its original spot. So it's going to swap it past 4, which is great. Then we're going to say, let's swap the second 3 into its rightful spot. If we're saying as long as the number, as long as the number is greater than 3, let's swap it. So it's going to say swap it here, but this is not greater than 3, so I'm going to keep it here, which is what we want. If we said as long as the number is greater than or equal to 3, then it would swap it again. And that would be bad because then our second 3, the one that should have come after the 3 one, would come before it. So that's the difference between having this as greater than or greater than or equal to, because we want to say keep swapping it back only if the numbers that I'm looking at are bigger, because I want to go to the left of those numbers that are bigger. But I don't want it to go to the left of numbers that I'm the same as, because those numbers would have originally come first, so I want them to still come first. So yeah, it is stable, but we need to be careful that with the greater than sign. It can't be greater than or equal to. And in terms of memory usage, again, this is going to be O of 1. We don't need to allocate any new arrays or anything as our input size increases. So again, whether or not we're working with an array of 1,000 elements or 1,000,000 elements, the number of variables we're going to create is just going to stay the same. We've got an I and a j, and that's it. So don't need to allocate any additional memory. And I guess this is what we're going to have to cut off today. What we will see is that when we move to merge sort on Friday, that there actually is going to be more memory that we're going to need to allocate to be able to solve it. Because at each step, or at least with the traditional merge sort implementation, because at each step it actually needs to kind of make these temporary arrays to kind of and put some elements into these temporary arrays. Any questions before we call it for today? I saw that I've got one no now, so, oh, maybe that was for questions. Okay, cool. But if that no is for, does the things make sense, then feel free to stick around and I can try to answer that question. No problem. I'll stop the recording then.